Today's focus will be on electrical circuits. So what is a circuit? A circuit is generally a rough circular route of movement that starts and finishes in the same place. Okay, so how does this apply to electronics? A circuit is a closed path from which an electric current flows. Okay, so if you think about it, it's just the path that if you have like a battery, okay, you have some wires connected to it, it goes to a light bulb, the light bulb goes on, and it goes back. This is a circuit. Okay, so you have to understand that it has to form basically a circuit. Think it forms a perfect circle. So would this guy work? Nope. And the reason why is because you don't have that, boop, you need that ending part, okay, to make it finish its circuit so it goes from the beginning to the end. Okay, would this work? Nope. And the reason why is because you need it to go to the bottom. Okay, you need the circuit to go from the top to the bottom of the battery. Would this guy work? Yes, because we have a perfect circle where we could form. Whoop, perfect. Okay, so why does it work? Why does it not? So once again, you don't have that perfect circle. You don't have a circle. You do have a perfect circle where it can go from point A back to point A without having to pick up your pencil or pen. Okay, this is called a closed circuit. A closed circuit means electricity can flow. Okay, it's closed. All right, so see how we have that path going from one to the other and then back up. Okay, you can go from point A back to point A without picking up your pencil, and it goes through everything that it would need to. All right, so will it light or will it not? And then if not, please circle where the problem is. Okay, so just to go over these, this is a battery, these are wires, this is a light bulb, and this is a switch. Okay, right now if you look at the switch, it is closed, okay, which means that the electricity can go from, well, it would go from the battery, but through here all the way through, and notice that it can keep following through. Okay, all right, so let's try to figure out whether these light or not. So the first one would. You could go from point A back to point A without picking up your pen or pencil. How about number 2? No, it would not. And the reason why is because it's got this switch on it. It's got that switch open. So notice that even though I'm starting here, going through here, whoop, I can't finish the circuit. Okay, with that one, nope. Okay, why? The reason, once again, is you have that open switch. Okay? Now, that would be the whole one. This one, would it? No. The reason why is because it does not go to the bottom of the battery. It would need to do that. Okay? Look at number 5. Would that? Yes, it would. You're able to go from point A to point B without picking up your pen. And looking at 6, would it? Yes, on the left-hand side. Notice you can go from here to here without any problems. And on the right-hand side, no. And the reason why is because of that open switch at the bottom. All right, there are a few parts of the circuit that you're going to have to know how to draw. And kind of what they do. So you've got a voltage source. Okay, that is your battery, that is your source of energy. You have a wire, you have a resistor, and you have a switch. Okay, so the voltage source is the one that supplies the energy. So we always wanted, in this class, we'll always be using a battery, okay, but it's the source of the energy. How you draw it is you draw one big line followed by a small line, okay? So if I have 2 batteries, what I will do is one big line, small line, and then a big line and a small line. You know how some of the appliances can use big and small, right? So, I mean, not big and small. You know how some appliances use multiple batteries? Well, this shows here that we have one voltage source followed by another voltage source. So we have 2 voltage sources for that one. So you just keep drawing long, short, long, short. Okay, that's a good one. You don't draw long, short, short, long. That is not, that means that they would be facing each other, and that would not be how you put batteries in, right? You keep them going in the same direction. Okay, you don't need to worry about these positives and negatives. Don't worry about that. All right, then you have the wire. The wire is what we think of as wiring, like electrical wiring, and that's the pipe where the current flows through, which are your electricity. This is where your electricity flows through. And all you do for a wire is you draw lines. Okay, so you connect them through lines. Okay, then you have a resistor. A resistor is any appliance that resists the flow of electrons more than the wire already does. So it increases the resistance, meaning it uses up some of that electricity. So here's an example of a resistor. Sometimes they draw a circle with an X through it that represents a light bulb. Okay, sometimes they draw it, but try to keep it easy on yourself. I personally either draw this one or this one. You will see other examples of how they draw resistors and light bulbs especially. But I think it's easiest to keep it simple, right? Okay, so this is literally anything that can use up electricity. So a light bulb, a toaster, a TV, computer, cell phone, everything, right? This would be what you would draw for that part that is using up the electricity. Okay, and then you have a switch. A switch is a switch, just like on the outlet on the wall. Okay, and a switch is if you turn it on, then it allows the electricity to flow, meaning it is a closed circuit. And if it is open, then it does not, and that means that it is an open circuit. So this switch is off, okay, because you cannot go from point A to point B by this, because it does not connect. Okay, this one is on. Okay, because you can go from point A to point B. Typically, how we'll draw it in this class is you draw like a line that represents your wire, but then you have a circle, and I draw a straight line. See how this guy right here is angled? You do not need to worry about that. And then another line. This right here represents your switch part. Okay, so this is one you would see in real life, and then they translate it to this. Okay, so let's try to do that. So first off, you have one battery. Okay, you have one battery, so one long line, one short line. Then you have a wire from here to here. So that's the wire from, this is actually backwards, because this represents the switch that is here. Okay, so this is not exactly the schematic. But anyways, so you go from a wire, we'll go backwards, wire from here to here, okay? And that represents your light bulb. So that would be this guy right here. And then we've got another wire that connects the light bulb to the switch, light bulb to the switch. And then we have your switch right here, right here. And then we've got another wire that goes from here to here. So it goes from here to here. All right, now this is exactly opposite. What I personally like to do is I put my finger on one and I start drawing it. Okay, so I'd be whoop, and then I draw a battery, and then I go, okay, what's the next thing that goes? Wire, then I'll draw the light bulb and things like that. Okay? All right, so let's identify the following from the circuits provided. All right, so we got to do the number of voltages, we have to do the number of resistors, we have to do the number of switches, and is the circuit opened or closed? Okay, remember an open circuit does not work, a closed one does. All right, so we've got our first one. Okay, so how many voltage sources do you guys see? That would be one right there. Okay, let's see the next one. Number of resistors, so things that use up electricity. That would also be one. That would be right there. How many number of switches? That would be one right there. And then is it closed or opened? It is closed because everything is connected from point A to point B, or from the start to the finish, without having to pick up the pen. So it would work. All right, let's try another one. Okay, so number of voltages. Okay, voltages here. So how many do you see? 1, 2. So that would be 2. How many resistors? I see 2 with the 2 light bulbs. See, these are another way that you can draw light bulbs. I personally still just do that. Boop, boop, circle with the X. Okay, that's easiest to me. Or squiggle line. That works. Okay, we're not being very specific on what resistor we're talking about when we're doing these diagrams. Okay, so number of switches for this bottom one, that would be 1 right here. Okay, and is it closed or open? It is open. Both bulbs would be off. It doesn't matter that it worked from the path from here to here. Okay, and it just messed up here. It has to be the complete circuit, otherwise everything is off. All right. Okay, so let's label the parts of the circuit here. So everybody look at this diagram. and we have the battery. How many sources would you say? I would hope you would say 2. 1, 2. Okay, let's try the next one. Here's your wire. Here's your resistor. And here is your switch. Okay, once again, I like the resistor being a circle with lines through it. Pretty easy. All right. All right, there are variables that go in a circuit. So not that you're drawing necessarily, but that are involved in it that vary how much of a circuit, how powerful of a circuit, things like that you've got. Okay, so those are voltage, current, and resistors. So voltage. Voltage is the force that pushes the current through, okay, the circuit. So it would be like gravity. You will have to know these, by the way. It would be like gravity. So on a waterfall, we're going to be talking about waterfalls a lot for this because we can visually see the waterfalls and then translate it to what it actually is, like in electricity. It's just a similarity. It's not actually how it happened. It's not exact, right? Okay, so it's how the voltage is the thing that drives the electricity through. So if this was the electricity, the water itself, the voltage would be like the gravity pulling that down, okay, the waterfall. Okay, it is also known as electrical potential. So if I say, what is its electrical potential, I am asking for its voltage, saying, how much potential does it actually have? Okay, what can it actually do with this? Its unit is volt, which is capital V. Source would be a battery or a generator. In this class, we will always be using a battery. And then its symbol is V. What I'm talking about with that is that in not chemical equations, in mathematical equations, in the formulas that we're going to be using, it will be V. Okay, then we have current. So voltage is like the gravity of a waterfall. The water particles themselves is like your current. What is current then when it's talking about electricity? It is the electrons. Okay, you can also think of water current, right? Water current is how much water you have, how fast it's going. It's the water particles, right? So in this one, it is the electrons, because what is the most important thing for electricity? The electrons, okay? So for current, it is the number of electrons, okay, that are flowing. So, or the amount. So it is, the unit is amperes. We abbreviate as amps, and its form in the formula, its symbol will be I. I know it makes no sense, okay, but it is I. All right. And then resistance. Think of what a resistance does. Well, it slows things down. So that's what this is. So resistance is the friction that impedes the flow of the current through the circuit. So anything that slows the flow of the electrons or the current will be your resistance. So that would be rocks in the river. The unit for that would be ohms, and it is the Greek symbol of ohm or mega. Okay, and then we've got our symbol for formulas is R. And water or current will, or the electrons, will try to take the path of least resistance, which means that the amount of resistance, they will always try to take the least. So the amount of resistance means that the longer the wires, you get more resistance. Thinner wires will also give more resistance. Why? Because it's not allowing that electricity to flow as easily. So if you have little short wires, the resistance will be down. If you have fat wires, your resistance will be down. Okay, so it kind of depends on what you want, but thin wires will lead to a lot more resistance. Okay, so let's try to describe the image that is being described below. So here's your voltage. This is your electrical potential. This is the thing that is doing the pushing. Okay, it is the drive. It is the drive of the electricity. And I would say it is like I would write down also that it is like your gravity for waterfalls. So it is pushing your current waterfalls. Okay? Your amps represent, this guy represents your current, which are your actual electrons. Okay, they're the things trying to move, producing the electricity. Okay, and then I would say that these are like the water in waterfalls. Okay, in ohms, this is your resistor. I can spell resistance. Well, I'll say resistance. Okay, what is they trying to do? Slow the current down. Okay, and what they do is also, they would be like the rocks slowing water down in a river. So things that slow things down. Okay? All right. There are a few types of circuits that you are going to have to know. The two that we will focus on are series and parallel. So series is the simplest kind of circuit. There is only one path that electricity can ever flow on these. Okay, so what it is, it's super easy to identify these, and I'll go over it more. But basically, you put your finger on point A. If you can get back to point A and touch absolutely everything in that circuit and get back to point A without picking up your finger, then that is a series circuit. Okay, they're very cheap and easy to make because you have a lot less wiring. It's very easy. You connect you kind of just keep the pieces kind of building off of each other. Problem is they're extremely easy to break. If you ever had one of those cheap Christmas lights, where sets of lights where if one light bulb goes, absolutely everything goes, that would be an example of a series circuit. Okay, now with this also, as you add more light bulbs, meaning more resistance, because they are the ones that are using up that electricity, slowing it down, the current reduces and the lights become dimmer. So if I add more to a series circuit, the lights will become dimmer. Okay, they will not stay the same. So if I keep adding more and more lights, they become less and less bright. Okay, how do I identify these guys as series? Okay, I'll just do the first one. I'm starting at my battery. I'm going to go all the way through my lights. I've got 2 resistors of lights. I've got a switch, and I go back and notice I did the whole circuit and I never picked up my pen. So this would be considered a series. Then we have parallel. Parallel are a little bit more complex. Electricity has more paths to flow, so they can take multiple paths. So they can take either option A or option B. They are more expensive because they are more wiring. They are more resilient, meaning if one light bulb goes, not all of them go. Okay, and for that reason, this is what is seen in your house. So anything that's a little bit more complicated, you will definitely be using parallel, because then if one thing goes, not everything goes. Like if I had a series system in my house throughout my entire house, if one light bulb went, absolutely everything in my entire house would not work. So that would not be productive, right? So what they do is they set it up in a parallel circuit. Okay, now as your resistance decreases, because we're adding more and more routes, okay, your resistance individually decreases. That means your current increases, and so they are inversely related. What I also want you to note is that as you add more and more light bulbs, they become the same as long as they are in a new parallel circuit. Their brightness will maintain the same brightness. Okay, as soon as you make it a part of a series, then it'll go dimmer, but as long as they are part of their own parallel circuit, that means that they are going to be the same brightness. All right, so let's look at the guy on the top. We'll do this one on the top right about this, why it's parallel. So I'm going to start from A, let's say, and then we go all the way. Okay, I'm going to go through resistor 1. Oh, look at that. I was able to get through resistor 1, but if you look at this guy, I never touched those, okay? And there's no route that you could take where you could go through all of these without backtracking. Remember, that's key. Also, you cannot backtrack in order to hit every single one of these resistors. So, oh, I could only do that one, or oh, I could only get that one done, right? So this would be a parallel series. And if you also look at it. They're like parallel. They're running parallel to each other, right? Makes sense. All right, so comparison of real life to the schematic drawing. So we have on here a battery. Let's try to figure out which one it is. Ooh, from A to B. Okay, so I touched everything, so that would be a series. Here, I'm going to go, oh, no. And then if I try a different route, oh, so this would be parallel. All right, so let's try to draw the schematic of it, though. So we've got our battery right here. Then we've got our 2 resistors or light bulbs. See, look at how they're drawn here. Different, once again. And then you have a switch. The only problem is that this switch is open, this one's closed, and then you've got your wiring. Okay? Then if we look at the one on the right, we have a battery. Boop. We have our light bulbs, 2 of them, in a parallel circuit. And then you go down and whoop, here's your switch. Once again, same problem with this one. It's open when it's really closed in the real life situation, but there's your drawings and your comparisons. Okay, so let's label these as parallel or series. So looking at the first one, that would be a series. Number 2 would be a parallel. 3 would be parallel, and 4 would be series. Okay, then you're also going to need to know this formula. Once again, we will give it to you. You just have to be rearranging it. And if you look at it, once again, it is our beloved triangle. Okay, so what the only weird thing is everything like I for current, that's weird. Like in amps, like all the units are very bizarre for what variable they're talking about. So that's the only confusing part I feel on all of these. So we've got our current, our voltage, and our resistance, which we've already talked about. And so this is the triangle. So it goes the current is equal to the voltage divided by your resistance. Or if you're trying to solve for voltage, you're going to take your current times your resistance, right? Or if you're trying for resistance, you're going to take voltage divided by current. Okay, and then you'll use these units and they just end up to be the new unit. It's not like it's, you're not going to have to figure it out. It's just pure memorization or looking at your formula sheet, either way. All right, and this is known as Ohm's law, right? It was named after the guy who figured this stuff out. All right, hopefully you guys understand a little bit about electrical wiring and things like that, everyday usage. All right, and have a great day.